This is Module 10, Section 5.5. In this section, we're going to look at multiplication of polynomials. Specifically, we're going to look at monomials multiplied by other monomials, monomials multiplied by polynomials, and polynomials larger than a monomial multiplied by polynomials. So, starting with multiplying monomials by monomials, or single terms times single terms. Remember that a monomial times a monomial is simply a term multiplied by another term. We did these problems earlier in this module when we were introducing properties of exponents. For example, let's say you were taking the monomial 8t to the 6th times the monomial negative 4t squared. Now notice there's no addition or subtraction in there, and so really that's all just a straight multiplication problem. And if you wanted to, you could rewrite that so it looked like this. You've got 8 times t to the 6th times a negative 4 times t squared. And also, if you wanted to, you could rearrange the order that those are written. Because of the commutative property of multiplication, it doesn't matter what order you multiply in. So if you wanted to, you could rewrite that as your constants first, 8 times negative 4, and then multiply that by your variable terms, t to the 6th times t squared. And at that point, that might make a little more sense to you. If you multiply your constants, 8 times negative 4 is negative 32. And to multiply t to the 6th times t squared, properties of exponents say that if you're multiplying like bases, you can combine those two by adding your exponents. And so this problem simplifies down to negative 32t to the 8th. And that would be your final product. All right, so in a similar fashion, we could do this next example. If we wanted to rearrange the order that those factors were written, we could. We've got a negative 2/3, and we're going to multiply that by a positive 1/8. And then that's going to be multiplied by x cubed from our first term times x to the understood 1 out of our second term. And then eventually we've got to put on that y squared factor as well. So let's do our numerical coefficients first. If you take negative 2 times 1, that's negative 2, over 3 times 8 is 24. Or if you want to, since this is multiplication, you could cross-cancel if you wanted to. That would save you from reducing in the end, which we're going to have to do. Okay, here you have like bases, so you can combine those by adding the exponents. And then y, which is a different base, will have to remain separate as y squared. So now we have, if we bring that up here, this fraction we're going to have to reduce. We can take out a common factor of 2. So negative 2 divided by 2 is negative 1. 24 divided by 2 is 12. X to the 3 plus 1 power, of course, is the same as x to the 4th. We have 4 x's. And y squared is our final product for that example. All right, what about when it's not quite that simple? What if you still have a monomial or a single term, but now you're multiplying it to a polynomial larger than a monomial? So for example, in this first example, we've got a monomial, 4a, being multiplied to a binomial, a squared minus 5a. Now this is simply distributive property, which you already know as well. So we're going to take that single term out front and we will multiply it to each term in the group that follows it to remove the parentheses. So that would give us 4a times a squared minus 4a times 5a. Or if we clean that up, 4a times a squared is 4a to the 1 plus 2 power. Remember, when you have a like base, there's an understood 1 there. you add your exponents, minus 4 times 5 is 20, and a times a, remember those are a to the firsts, so we've got a to the 1 plus 1 power. And if we clean all that up, we've got 4a cubed minus 20a squared. The operator between those two monomials is subtraction, so you need like terms. You don't have like terms, so that's as far as you can go for that particular multiplication problem. All right, this example here, this is a monomial times a trinomial. So we're going to multiply that 2xy to each term in the group, distributive property. So we've got, and I'm going to use parentheses this time instead of a multiplication dot. I think it's a little less messy. So I've got 2xy times my first term, which is 2x, minus 2xy times my second term, which is 3y, plus 2xy times 4z. All right, for each of those multiplication steps, you're simply going to multiply using properties of exponents where appropriate. So 2 times 2 is 4. X to the first times x to the first would be x to the 1 plus 1, or x squared power. And then that's additionally being multiplied by y. So 4x squared y minus 2 times 3 is 6. X, there's only one x in there, nothing to combine it with. Here we've got a couple of y's though. Y to the first times y to the first is y to the 1 plus 1, or y squared. Y times y is y squared. Plus 2 times 4 is 8. X times y times z, those are all different bases, so they will just multiply together in that final term. Now you have a subtraction step and an addition step. In order to combine anything more, you'd have to have like variable pieces, like terms. You don't have that, and so that is your final answer in that problem. Okay, now, what if you're multiplying a polynomial by a polynomial, where both polynomials are larger than a single term? There are several methods for multiplying polynomials by other polynomials. Some methods work for any size polynomials, and some only work for binomials multiplied by other binomials. We will first discuss 3 methods that work for any polynomials. Okay, method 1, the distributive property method. This method is the same as any other distributive property problem, except that now we are distributing a group rather than a single term. So before, we were doing problems like this. We were taking maybe 2a times x minus y, where we took that single monomial and we multiplied it to each term in the group that followed it, and then went ahead and simplified where possible. This is exactly the same, except that instead of distributing a single term, we're actually going to take a single group and multiply it to each term in the group. All right, so to do that, we're going to take that group, and you need to keep the parentheses because it's the whole group times that first term in that second group. So we've got the group 2a minus 3b times 4a minus the group 2a minus 3b times that b. All right, now at this point, we have distributive property again. We've got a group times a single term. Now, as it's written here, you'd be distributing from the back. That bothers a lot of students, so if you want to, you can flip-flop the order of those groups around if you want to. You can write the monomial first and write the 2a minus 3b group second, if you like the look of that better. The reason you can do that is because of the commutative property of multiplication. It doesn't matter what order you multiply in, you're going to get the same answer. So I can do the same thing for my second term here. If I want to write my b before my group instead of after my group, that's okay. It's the same thing. Okay, and that step is unnecessary. It's up to you. If it doesn't bother you to distribute from the back, that's fine. So now we're going to distribute again. So this is actually a double distribution step. We've got 4a times 2a minus 4a times 3b. Now you want to be careful here. You have to distribute not only the b, but also the subtraction sign to each of those groups. So if that bothers you, you can change that to plus and negative. Okay? So now we've got plus negative b times 2a minus negative b times 3b. Do the multiplication steps. It's now an orders of operation problem. 4 times 2 is 8. A times a, add the exponents. 1 plus 1 is a squared. Minus 4 times 3 is 12. A times b is just that, a times b, because those are unlike bases. Plus 2 times a times b, except it's a negative b, so it would be negative 2 times a times b. Now notice here we have a double negative. Double negative is a positive. 3 times b times b times b is b squared. All right, we've got like terms here we can combine. So we've got 8a squared minus 12 plus negative 2 is a negative 14. So I'm going to write that as subtraction. Minus 14ab plus 3b squared. Those are all unlike terms. You can't combine them. That would be your final simplified answer for 2a minus 3b times 4a minus b. All right, so using the distributive property method, let's multiply these two problems together. Okay? Distributive property method now distributes a group. So we're going to take that group and multiply it to each term that follows it, which gives us the group y plus 3 times y squared minus the group y plus 3 times 3y plus the group y plus 3 times 9. Okay, I'm going to put those constants out front. So I've got, I'm sorry, not constants, our monomial terms. This is the same as y squared plus y plus 3 minus 3y times y plus 3 plus 9 times y plus 3. I just flip-flopped the order we were multiplying there. Okay, the reason I prefer that form is because then if there's a subtraction ahead of that distributive property step, I can easily see that. Okay, so I need to distribute the y squared, I need to distribute the minus 3y, and I need to distribute the plus 9 to the group that follows it. So this is your second distributive property step. We've got y squared times y to the first. That would give us y cubed, add the exponents, 2 plus 1 is 3, plus 3 times y squared is 3y squared. Here we've got minus 3y times y. That would be minus 3y squared. And minus 3y times plus 3. Minus 3 times plus 3 is minus 9, and then of course the y is also being multiplied there. Okay, next step, positive 9 times y is plus 9y, and positive 9 times plus 3 is plus 27. Okay, combine any like terms. We're going to bring it up here. We've got y cubed, and that's the only y cubed term, so there's nothing to combine there. We've got a 3y squared and a minus 3y squared. 3 minus 3 is 0, y squareds. 0 times anything is 0, and so these two terms cancel themselves out. Notice we've also got a negative 9y and a positive 9y. Negative 9 and positive 9 also cancel themselves out. So the only thing left is plus 27. So our final answer there, after combining like terms, is y cubed plus 27. All right, let's do our next polynomial times polynomial. Again, using the distributive property method, we're going to take that whole trinomial group and multiply it to the individual terms of the group that follow it. So we've got, parentheses are important, the group 5x squared minus 3x plus 4, that whole group times x, minus the whole group 5x squared minus 3x plus 4 times 3. Again, I'm going to take those single terms, single factors, and pull them out front because I like that better. So I've got x times 5x squared minus 3x plus 4 minus 3 times the group 5x squared minus 3x plus 4. Now we're going to take those terms and multiply it to each group that follows it. Here, make sure you distribute both the 3 and the minus, or multiply by a negative 3. So here, x times 5x squared would be 5x cubed, 1 plus 2 is 3, minus 3x times x is 3x squared, plus x times 4 is 4x. Now, minus 3 times positive 5x squared is minus 15x squared. We've got minus 3 and minus 3x. Negative times negative is a positive 9x. And minus 3 times positive 4 is minus 12. Combine any like terms that you see. We've only got that one cubed, so I'm going to put that up here. I've got 5x cubed. I've got a couple of x squared terms. I've got negative 3x squared and negative 15x squared. Negative 3 and negative 15 is minus 18 x squareds. I've got positive 4x and positive 9x. 9 plus 4 is positive 13x. And for constants, all we have is the minus 12 at the end there, I believe. So minus 12 on the end. Those are all unlike terms. You cannot combine them. So that would be your final answer for that problem. All right, so method 2 is the vertical or column method. This method is very similar to traditional vertical multiplication, except you don't need to worry about carrying or place value, but rather simply carry all signs and make sure like terms are in columns underneath one another, because that makes combining like terms easier. All right, so we're going to take this problem, this binomial times this second binomial, and we're going to write it like it was a traditional multiplication problem that you did in columns. Now again, in grade school, when you did column multiplication, you had to worry about shifting over and putting in placeholder zeros and things like that. In this case, you don't need to worry about that. You just need to be careful about sign, and you want to column up like terms. Okay? So just to give you an example, let's say that you were doing 23 times 42. You know that from grade school, you were taught to start with the lower number and the place value farthest to the right, and you multiplied that value to each term above it. In other words, you took 2 times 3, and that gave you 6, so you wrote that number down. And then you took 2 times 2, and that gave you 4, and you wrote that next to it. Okay? Now over here, we're going to do the same thing. Over here, carry the sign, we're going to take a negative b, and we're going to multiply it to everything above it, and write it underneath our bar. So let's do that. We've got negative b. We're going to multiply that by a negative 3b. Negative times negative is a positive, and 3b times b is 3b squared. Add the exponents of the like bases. Okay, then take negative b and multiply it to 2a. Negative times positive is a negative, so you've got a negative 2. And a times b is just that, a times b. All right, now over here, what you did is then you shifted over to the next value, and you multiplied that to everything above it. Now there were a couple of things you had to worry about for this multiplication problem here on the right. When you shifted over to your next place value, shifted over to the 4, you had to put in a placeholder 0 so that like place values would column up. You don't have to worry about that over here. Okay? Over here, you took 4 times 3 and you got 12, and then you had to carry that 1 into your next multiplication step. You took 4 times 2 was 8, and then you added another 1 to it. That gave you 9, and you wrote that in the next column. Over here, you're going to do the same thing. You're going to take that positive 4a and multiply it to everything above it. But the difference is you don't have to worry about shifting over necessarily, and you also don't have to worry about carrying. You just have to be careful of your sign. And when you write things down, try to column it under a like term if there is one. All right, so first we're going to take 4a and multiply it to negative 3b. 4 times 3 is negative 12. A times b is ab. So 4a times negative 3b is negative 12ab. And notice that I did shift over simply because that allowed me to column it up underneath my other ab term. I've got like terms in a column. Okay, now I'm going to multiply 4a times 2a. 4 times 2 is 8. A times a is a squared. So I've got 8a squared. I don't have a column with a squared anywhere, so I'm going to write it out over here because I don't have anything to column it up under. All right, so moving back to the right for this traditional problem, what you did after you did those multiplication steps is then you added your columns. 6 plus 0 is 6, 4 plus 2 is 6, and then you carried down the 9, and that was your answer. You're going to do the same thing here. You're going to add columns, add like terms. If there's only one thing in the column, then you'll just carry it down. So we've got plus 3b squared. Here we've got like terms, so negative 2 and negative 12 is minus 14ab. And out front, with nothing to combine with it, is 8a squared. And there's your answer. 8a squared minus 14ab plus 3b squared. All right, so using the column method, let's multiply these two examples. Y plus 3 times the group y squared minus 3y plus 9. I'm going to choose to put the larger polynomial on the top. That's just a personal preference. It really doesn't matter. Okay? I'm going to put the y plus 3 underneath it. Okay? And then I'm going to, like traditional multiplication, start on the lower right-hand side and multiply that positive 3 to everything above it. So positive 3 times positive 9 is a positive 27. Positive 3 times negative 3y is a negative 9y. And positive 3 times y squared is a positive 3y squared. Now I'm going to take my positive y and multiply it to everything above it, keeping in mind that I'd want like terms to fall in a column. So y times 9 is a positive 9y. Y times negative 3y is negative 3y squared. And y times y squared is positive y cubed. If you add that up, Notice that, and this problem we did before with the distributive property method as well. Negative 9 and positive 9y is 0. So is positive 3 and negative 3y squared. So we're left with a final answer of y cubed, which is right there, plus 27. Same answer we got before with distributive property using the vertical or column method. All right, let's do this problem. Let's do 5x squared minus 3x plus 4 times x minus 3 using the column method. Make sure you carry the sign. So we want to take minus 3 and multiply it to everything above it. So minus 3 times positive 4 is minus 12. Minus 3 times minus 3x is a positive 9x. And minus 3 times 5x squared is minus 15x squared. All right? Now we're going to take that x and multiply it to everything above it. So x times plus 4 is plus 4x. X times minus 3x is minus 3x squared. And x times 5x squared is a positive 5x cubed. Add your columns, combine like terms, and you get 5x cubed minus 18x squared plus 13x minus 12, which should be the same answer we got when we did that problem with our distributive property method. All right, that was the column or the vertical method. Method 3, which also works for all polynomials, is the area method. This is an interesting way to view these problems. You are drawing a picture showing the area represented by each term in the polynomials, and then simply adding up all the areas to get your final area of the entire picture. So, here's what you're going to do. You're going to look at the two polynomials in the problem, and you're going to let the terms in one of the polynomials represent row values for a table, and you're going to let the other polynomial represent columns in your table. So since both of these problems are binomials, that means I'm going to need 2 rows and 2 columns. So we're going to draw a rectangle, or in this case a square, since those are about the same. And if you let these terms represent your row labels, now carry the sign. My row labels are going to be a positive 2a and a minus 3b. My column labels are going to be positive 4a and minus b for my second column. And you can flip-flop that around. If you want your columns to be that first group and your rows to be your second group, it's not going to matter. Now for each intersection, okay, row and column, that's a multiplication step. So to fill in that first upper left-hand box, we're going to take 2a times 4a. It's multiplication. So 2 times 4 is 8. A times a is a squared. All right, in the upper right box, we're going to take 2a and multiply it to negative b. So positive times a negative is a negative 2, and a times b is a b. Okay, this column down here, we're going to take this row, negative 3b, and we're going to multiply it to positive 4a. So negative 3 times a positive 4 is negative 12, and a times b is a b. And finally, for your lower right, we're going to take negative 3b times negative b. Negative times negative is a positive 3. B times b is b squared. Okay, so now we're going to take each of those terms that we have in that group, we've got 8a squared minus 2ab minus 12ab plus 3b squared combine like terms, and we get 8a squared minus 14ab plus 3b squared for our final answer. All right, so let's do these two problems, which again we've done twice before, but we want to make sure we get the same answer using the area method. Okay, we're going to go with our first group being our rows and our second group being our columns. So here for this matrix, we're going to need 2 rows but 3 columns. So we'll make it a little bit bigger than I did before. 2 rows and 3 columns. Our row labels are going to be positive y and positive 3. Our column labels, y squared minus 3y plus 9. All right, and do the appropriate multiplication row and column for each of the labels for each box. So for our first box, y times y squared is y cubed. Add the exponents. Next box to the right, y times minus 3y is minus 3y squared. Third box upper right, y times positive 9 is positive 9y. Now let's move to our second row. 3 times y squared is 3y squared. 3 times negative 3y is negative 9y. And 3 times 9 is positive 27. Okay. You can rewrite that like I did the previous problem, or you can just look for like terms in the area model. You've got some like terms here. You've also got some like terms here and here. In this case, this is the example where our positive 3 and our negative 3 canceled out, and so did our negative 9 and positive 9y. So what we're left with, as with the previous 2 methods, is y cubed plus 27 as our final answer. All right, let's do this one. Now this is our rows, and this is our columns. So now I need 3 rows and 2 columns. So 3 rows, 2 columns. Looks about right there. 3 rows, 2 columns. Our rows are going to be labeled 5x squared, negative 3x, and positive 4. Our columns, x and negative 3. Okay, and do your multiplication steps. We've got 5x squared times x is 5x cubed. We've got 5x squared times minus 3 is minus 15x squared. We've got negative 3x times x is negative 3x squared. We've got negative 3x times negative 3. Negative times negative is a positive 9x. We've got 4 times x is 4x. And we've got 4 times minus 3 is negative 12. Okay, let's look for like terms. There is no other cubed term except for this one right here. So I'm just going to rewrite it, 5x cubed. Then I've got a couple of x squared terms. I've got negative 3 and negative 15. Negative 3 plus a negative 15 is negative 18, or minus 18 x squareds. We've got positive 9x and positive 4x. 9 plus 4 is plus 13 x. And then the only thing left there is our constant by itself. That's minus 12. And there is the answer, and it should be the same answer we got before using the other 2 methods. Now we will discuss a method only to be used for a binomial multiplied by a second binomial. So although I do have this labeled as method 4, you need to recognize that this is a special case method that only works for 2 terms multiplied by 2 terms. So method 4, or the FOIL method, works like this. FOIL stands for first, outer, inner, last, with addition between each of those steps. Now, first, outer, inner, last are each multiplication steps. F, or first, is the product of the first term in each group. O stands for outer, which is the product of the outer terms as you look at the problem. I stands for inner, which is the product of the inner terms as you look at the problem. And L stands for last, which is the product of the last term in each group. Then after you've determined each of those products, you do add them together for your final answer. All right, so let's look at this problem. Okay, let me label first, outer, inner, last for you. Okay, first, remember, was the product of the first term in each group. So the first term in each group, in this particular example, will be 2a times 4a. That's our first product. Outer means the outer 2 terms as you look at the problem as it's written. So the outermost term on either side would be our positive 2a and our minus b. That's our outer product. So outer, over here, would be 2a times minus b. Okay, carry the sign. Inner means the innermost terms as you look at it. So the innermost 2 terms is the negative 3b and the positive 4a. So over here, we've got negative 3b times positive 4a. That's our inner product. And our last, I'll have to squeeze that in there. Last 2 are always the last terms in each group. So last terms in each group would be the negative 3b is the last term in the first group. Negative b is the last term in the second group. Those are your last 2 that you're going to multiply. So that will give you, I'm going to write it down here, negative 3b times negative b. And to get your final answer, you will add all of those products together. So let's see what we get. 2a times 4a is 8a squared. 2a times minus b is minus 2ab, or plus a negative 2ab if you like that better. Here we've got negative 3b times positive 4a. Negative 3 times positive 4 is minus 12, or plus a negative 12. And a times b is a times b. And this last product, negative times negative, is a positive 3b squared. Combine like terms, and you've got 8a squared minus 14ab plus 3b squared. And that's your answer. All right, so let's FOIL out this problem. We've got first 2. That would be the 3y and the 4y. So we've got 3y times 4y, and I'm going to go ahead and just do that multiplication. That gives me a positive 12y squared. Outermost terms would be 3y times minus 9. 3 times minus 9 is minus 27, and there's a y attached to that. Inner product will be the inner 2 terms, so that's a positive 4 times a positive 4y. 4 times 4 is plus 16, and then the y is attached. And last 2, I've got a positive 4 times a minus 9. Positive 4 times a minus 9 is a negative 36. Now we're going to combine like terms. Negative 27 plus 16 is, let's put it up over here. Negative 27 and plus 16 is a minus 11y, I believe. And we still have that 12y squared out front. And we've got that minus 36 tacked on to the back. All right, now let's look at these problems. These problems we're also going to use with the FOIL method. These are written a little bit differently, but recognize they really are binomial times binomial. Here, anything squared is your base multiplied by itself. So in this case, this is the same as 4x plus 5 times 4x plus 5, because it's the quantity squared. So to FOIL that out, we'd want to multiply the first two terms together. 4x times 4x is 16x squared. Our outer product would be the outer two terms. So positive 4x times positive 5 is a plus 20x. Our inner product will be a positive 5 and a positive 4x. So again, that's plus 20x. And then our last two, positive 5 times positive 5, positive 5 times positive 5 is plus 25. Combine like terms, and you get 16x squared plus 40x plus 25, and then everything left are unlike terms, and since that's addition, you have to have like terms to go further. All right, so let's do a minus 3/4 times a minus 1/4. If we FOIL that out, we're going to multiply the first two terms together. A times a, that's a squared. Outer two terms would be a times minus 1/4, which is minus 1/4 a. Inner two terms, which would be here and here, negative 3/4 times a is minus 3/4 a. And last two, make sure you carry the sign. Negative times negative is a positive. 3/4 times 1/4, I'll actually multiply that out over here. 3/4 times 1/4, multiply straight across, and you get plus 3/16. 3 times 1 is 3, 4 times 4 is 16. Here I've got like terms to combine, and I'll do that up here. Minus 1/4 minus 3/4. I do have a common denominator, so do the math up top. Minus 1 minus 3 is negative 4 over 4, which is negative 1. So here we've got negative 1a, and we have that a squared as well. Now let's clean that up. No like terms to combine. I'm just going to rewrite it and drop that coefficient of 1. Our final answer is a squared minus a plus 3/16. And that would be our final answer for that problem. This is the end of Module 10, Section 5.5 material. You now should complete the homework for Section 5.5 found in My Math Lab. When you have successfully completed the above homework, proceed to the video for Module 10, Section 5.7.